In RF engineering, a binocular combiner, often called a binocular transformer combiner, is a passive device used to sum the power from two separate linear amplifiers into a single output while maintaining proper impedance matching and isolation. It is named for the binocular shape of its ferrite core, which contains two parallel holes through which windings are threaded. VU2 GTX recently tested a similar setup using two VU2 EVQ linear amplifiers, each with 100 watt output, with a driving signal of 5 watt from a Kenwood radio. I could hear an excellent signal on 40 meter band. I ordered two VU2 EVQ linear amplifier boards, which I hope to get in a week or so. It will be a tough project to first assemble the boards and then combine the outputs using a binocular combiner. Input from my FT710 radio will have to be routed through a splitter to provide equal signals to both boards in phase. We'll have a look at the key functions and characteristics of the binocular combiner. Power summing. It combines the output of two identical amplifiers to achieve a total power level higher than a single unit could provide. For example, combining 200 watt amplifiers can reach nearly 200 watt of output. Impedance matching. The combiner acts as a transformer to match the lower output impedance of the individual amplifiers back to a standard 50 ohm load. Isolation and balancing. It typically includes a balancing isolation resistor, often 100 ohms. If the two amplifiers are perfectly matched in phase and amplitude, no power is dissipated in this resistor. If they differ, the resistor dissipates the difference to prevent one amplifier from feeding into the other. Feeding output of one amplifier into the other could cause instability, intermodulation distortion, or damage. Phase requirement. For optimal performance, the input signals to the amplifiers must be in the correct amplitude and phase relationship so that they combine additively. This usually means the signals are in phase, requiring a power splitter at the input stage to divide the source signal accordingly. Broadband performance. Unlike resonant filter based combiners, binocular transformer combiners are designed for broadband use, frequently covering ranges like 1.8 to 54 MHz. Applications of binocular combiners in linear amplifiers. Increasing transmit power, used in high power amateur radio and commercial transmitters to reach legal limit power levels by using multiple solid state modules. Thus, it is possible to increase the overall transmit power without needing a single more expensive higher power transistor or vacuum tube. Redundancy. By using two separate amplifiers, a station maintains availability even if one unit is removed for field use or maintenance. Signal linearity. Combining signals at high power can cause distortion. A binocular combiner helps manage multi-signal systems with low nonlinear distortion.